calculate the class width of this data and construct a frequency distribution for this data set using 6 classes. Enter the lower and upper class limits of each range in the respective boxes, and then fill in the corresponding frequency. Alright, so when we have a set of data, we have to first calculate our class width through the formula. The class width is equal to the maximum data entry minus the minimum data entry divided by the number of classes that we want to have in this set. So we're told here that we need 6 classes. That was just given to us in the problem, and that will generally be given to you because otherwise it makes grading hard. Then we have to kind of dig through the data and find out what our minimum and maximum are. So let's see, 16 looks pretty small. I think that's the smallest. 73 looks like it might be the largest. No, there's a 75 there. And I believe those are the correct ones. All right, so I need to take the maximum of 75 minus the minimum of 16 and then divide by 6. All right, so help with the calculator here. 75 minus 16 is 59, and we divide that by 6, we get 9.8333. Now, we don't want to use a non-integer value here because all of our data is integer-based. So we're going to round this, but there's a different rounding rule that we use here. It's called ceiling. The ceiling of a number is you always move up to the next integer, in contrast to floor. And the floor of a number is that you always round down to the low, or basically you truncate, you remove the decimal portion. But the ceiling of a number, you always go up. So the rounding rule is for class width. You always round up to the next integer. So this is going to initially be 9.83. But we will round up to 10. Okay, so that's my class width. Class width is 10. Now, to create the classes, what I do is I start with my minimum data entry, and that minimum data entry was 16, and I start my very first class with that minimum data entry. Then I take my class width and add it to the 16, which gives me 26, and that is the start of the next class. It's tempting to try and put that 26 right over here, but unfortunately that's not the way we do things here. If you did that, you wouldn't actually have 10 potential items to fit into that class range. So this is how we go about it. And we just repeat the process for the rest of the classes. So 36, 46, 56, and 66. And that is the 6th number, so that means I've got 6 lower class limits. Now I will go and get the upper class limits. So for the upper class limits, if I want the second class to begin at 26, then I'm going to need the first class to end at 25. And that way I have a place for all the different data items. And then I can take that 25 and continually add the class width to it. So that would be 35, 45, 55, 65, and then 65 plus 10 is 75. And now I've created my class ranges. The frequencies, what I do here, I generally will start a set of tally marks and just go through the data set one by one, fitting each item into a class range. So for instance, 53. So that's going to be here in the third class. So I'm going to put a tally mark in the third class. Another 53 is in the same. Then 20, so come up to the first class. 25 is in the first class as well. 35 is in the second class. 38 is in the third class. 73 is in the 6th class, then 16, and we just go one by one, fitting our data into each class. So then 37, it's here, 59 is there, 66, 21, 72, 36, 75, 69, 37, 22, and 28. All right, so as long as I haven't fit accidentally any of these values into the wrong class, which can happen, but just try to be careful because the computer's not really forgiving about that thing, but your professor probably is on a test. Now we can fill in the frequencies. So I have a frequency of 5 for the first class because there's 5 tally marks, and a frequency of 2 for the second class, then 4, 2, 2, and 5 for the last class. And that's our frequency distribution.